I'm Rayesh Uppal, founder of IDST. We bring you sharp insights and foresight on emerging tech, defense, and security. Let's dive in.
The world of biology is being reshaped by one of its most fundamental processes, gene expression. It's the way DNA instructions are turned into proteins and are not the molecules that keep our cells alive and functioning. But beyond being a fascinating process of life, gene expression has become the foundation of a booming global market, one that's transforming healthcare, biotechnology, and even agriculture. So, what's driving this surge? Let's break it down. Gene expression works through two critical steps: transcription, where DNA is copied into messenger RNA, and translation, where that RNA is used to make proteins. This process determines whether a cell becomes a neuron, a muscle fiber, or even how it responds to stress. When something goes wrong, when a gene is overactive or silenced at the wrong time, the consequences can be serious. Cancer, genetic disorders, neurodegenerative diseases. That's why studying gene expression isn't just about science for curiosity's sake. It's the key to diagnostics, drug development, and the next generation of personalized medicine. And right now, the global gene expression market is on fire. Valued at about $13.85 billion in 2023, it's expected to soar past $37 billion by 2033, with a compound annual growth rate of more than 10%. North America leads the pack, with nearly half the global revenue share, but Asia Pacific is catching up fast, fueled by research funding in countries like China, India, and Japan. What's behind this growth? Technology. Innovations like real-time PCR, microarrays, and next-generation sequencing, or NGS, have revolutionized gene expression analysis. RNA sequencing in particular has become a powerhouse tool, letting researchers explore how genes behave across thousands of cells at once, or even down to a single cell. Combined with powerful bioinformatics and AI tools, these methods make it possible to sift through massive data sets and uncover patterns that were invisible a decade ago. This wave of innovation is fueling the rise of precision medicine. Instead of a one-size-fits-all approach, treatments can now be tailored to a patient's genetic profile. Imagine giving a cancer patient a drug that's selected not just based on their diagnosis, but on the specific gene expression patterns of their tumor. That's the promise, and it's already happening in oncology and rare disease research. But the applications go far beyond human health. Agriculture is tapping into gene expression to engineer crops that resist pests or survive drought. Industrial biotech companies are using it to develop biofuels and sustainable materials. It's a market that cuts across healthcare, pharma, research labs, and agriculture alike. Of course, no story of rapid growth is complete without challenges. These technologies are expensive. High-end sequencing and bioinformatics platforms can be out of reach for smaller labs or developing regions. And then there's the data. Gene expression studies produce mountains of it, requiring skilled bioinformaticians who are in short supply. On top of that, ethical and regulatory concerns loom large. How do we safeguard genomic privacy, ensure informed consent, and prevent misuse of genetic data? These are questions that the industry still needs to answer. But the momentum is unstoppable. With AI and machine learning stepping into genomics, CRISPR and gene editing reshaping the way we study gene regulation, and advances like single-cell and spatial transcriptomics giving us a never-before-seen view of cellular life, the future of gene expression analysis is brimming with potential. So, whether it's cracking the code of cancer, making medicine more personal, growing resilient crops, or powering the biotech industry, gene expression is at the heart of it all. And as the market grows, one thing is clear: understanding our genes isn't just a scientific pursuit anymore. It's a business, a technology, and a future-defining force.